Welcome to our series on clean energy and energy efficiency. Throughout the series we will have some short 5-minute to 10-minute lessons on key concepts and best practices for you to do in your school as well as your community. Today we're going to study about how a solar cell works. Solar cells are traditionally made of silicon, which is a group 4 material, silicon. And the silicon material is thinly sliced in the form of a silicon wafer. And these wafers have metallization, and once they're completed, obviously you've seen these silicon solar cells put together, and when they're put together right next to each other and string tied, then they become a large solar panel, is what you traditionally see on top of a rooftop in your residential area or commercial building. So how does the silicon solar cell work? If I magnified a cross-section of the wafer, or silicon wafer, then we have silicon. Silicon is a group 4 on the periodic chart, so group 4. If we dope the top portion with a group 3, for example boron on the periodic chart, you put boron into the material, it becomes a p-type, p-n junction side, positive side. Now on the N side, we would put in a group 5. Group 5 would be, let's say, phosphorus, for example. So phosphorus, if we put in here, phosphorus here, then it becomes a N-type. So silicon is group 4 as the base material. You put in group 3, becomes positive. Put in a dopant of phosphorus, group 5, then it becomes an N-type. This forms what we traditionally have, and you may have heard, it's called a p-n junction. So p-n junction or p-n diode. Right? P-n junction or diode. Now, in the case of the solar cell, we have a source of energy in the form of light coming from the sun. This energy comes in, it's absorbed at the p-n junction, the interface between the positive side and the negative side, and it creates an electron and a hole pair. And as that electron and hole are swept across that junction, we begin to get a reading current flow. So when the current flows, it generates an electric current flows, and you can do work with that. In the case of a diode that generates light, as in I have here a traditional LED or light emitting diode flashlight, it's also a diode, as in the case of light emitting diode. It works the opposite of a solar cell. In the case of the solar cell, as a reminder, light comes in, electron hole pair gets generated, and then it forms current, so you get electricity coming out. In the case of an LED, light emitting diode, you pump in current, so you put a battery or source of electricity, you pump in current, electron hole pairs, and when they recombine, you actually get light out. So light comes out when you pump in current. So in summary, a solar cell uses a typical silicon wafer. You get a P side and an N side, positive side, negative side. That forms a large diode, a large p-n junction diode. When the light is shown on the diode, it generates an electron hole pair. Electron hole pairs are swept across the junction, and it creates current, creates electricity, and that's how solar cells create electric current. And in the opposite way, a similar semiconductor diode that emits light has current come in and light comes out. So it works just the opposite, but they're both forms of semiconductor diodes. Thank you.